Welcome to today's KM World webinar, brought to you by LucidWorks. I'm Mary D. Ojala, Conference Program Director, Information Today, Inc. I will be the moderator for today. Now, before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session, so if you have a question during the presentation, just type it into the question box provided and click on the Submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response to it within a few days. And if you would like a copy of the presentation, you can download a PDF from the resource icon on the console once the event is archived. And now, let me pass the event to Justin Sears, VP Product Marketing, LucidWorks. Justin.
Thank you so much, Mary D. It's really a pleasure to be here with you all today. I'm really excited to be presenting with Carl Hampson from Solstice. So this is the Apply Knowledge Graphs and Search for Real-World Decision Intelligence webinar. If this is the webinar you are intending to join, you can drop off now. Otherwise, let's just jump in. I'll give a brief introduction to myself. Like Mary D. mentioned, I run product marketing at LucidWorks. We work on analyst relations, positioning, messaging, etc. And I came to LucidWorks from about 8 years of prior experience in venture-backed big data analytics companies, including Hortonworks, which was the big open source Hadoop provider. So that's a bit about me. Let me turn over to you, Carl, to introduce yourself and kick off the presentation.
Thanks, Justin. So hello, everyone. I'm Carl Hampson, CTO of AI and Data at Kin + Carter Solstice. I've been working with search and human-friendly information for over 20 years. Of particular interest to me today is this next generation of intelligent search, which goes beyond just matching the keywords to more semantic and natural language approaches, which help connect users, customers, and employees with the most relevant content to make effective decisions. And one of the exciting ways to achieve this is using something called knowledge graphs. So I just want to start by separating the idea of graphs as a data structure, if you like, from knowledge graphs, which is the application of that concept to encode knowledge. We actually all engage with knowledge graphs every day using Google, Facebook, and LinkedIn. They're kind of hiding there in plain sight. Knowledge graphs first came into my consciousness with Google in 2012. When they launched this whole idea of things, not strings. So when you query about a thing in Google, you also get this panel showing details about that thing and not just the listed results. So a knowledge graph ostensibly captures and encodes facts, and it typically represents a specific domain. So by way of example, one of my favorite parts of London, Tower Bridge, River Thames. So this is basically showing that Tower Bridge is located in London. Tower Bridge spans the River Thames, and the River Thames passes through London. The relationships between those nodes and edges, if you like, to use the correct terminology. And you can imagine that this structure can be extended quite dramatically to encode knowledge. There's lots of uses of knowledge graphs, including things like data integration, knowledge discovery, and in-depth analysis, and we're going to focus on how they apply to search specifically. So now we've established the concept of a knowledge graph as a powerful way to encode these kind of facts. How do we tie it in? Well, key to understanding this really is just to understand how we might actually create one. So, many of us are familiar with things like mind maps, the idea of a sort of manual process to capture our knowledge, if you like. Wouldn't it be great if a computer could kind of do something like this for us automatically? Well, what's interesting with search is that a typical search index already contains lots of related things in the content. And the context, if you like, of that specific domain is already there in place. So what you might kind of think of this as is, rather than thinking of it as sort of unstructured content, it's actually hyperstructured content, but we need a way to extract the value that's sitting in that index. So if we can somehow harness and unlock this as a graph, then it provides us with this new way to navigate, engage, and extract value from our search index. And semantic knowledge graphs as a feature of LucidWorks can basically do this for us automatically. So the semantic knowledge graph feature, it's exposed as a simple API against your index documents, and it's basically there and ready to be leveraged instantly by any application. So the image on the right is showing a kind of sample of a semantic knowledge graph for a concept of software developer and all the related roles in the graph around that, if you like. So you provide a query string and the graph is generated automatically, and we can then effectively navigate from one level to another. So you can imagine taking any of those other related roles around the outside, putting that in the middle of the graph, and then re-navigating and getting all the related things allows you to jump from one concept to another. And you kind of think of this as a sort of ready-to-go data science toolkit. And it's very powerful functionality, which we can use for a number of use cases, and we'll get into some of that in a second. So I just want to go back to this idea of actually graphs, knowledge graphs, semantic knowledge graphs. In a traditional knowledge graph setting that some of you may have heard of, it's this idea of, if you like, encoding facts. So a Tower Bridge is located in London. You can use technologies such as natural language processing, NLP, to extract these textual facts from documents and build up your knowledge graph. And as you might imagine, it's a complex process. You get lots of duplicates, conflicts, noise, and at the end of that, you'll end up with a static data set, which also needs to be maintained. So this is ostensibly what Google are doing. The barrier to entry is pretty high, and ultimately it's quite a specialist area to do this. Can be done, but it is a specialist thing. Just want to compare that to the idea of a semantic knowledge graph, which is something that's generated for us dynamically from our search index. So rather than getting this idea of a fact, what we're getting are the related things and the degrees of relevance between them. And this is in a ready-to-go API, and as I said, it has an immediate value. So what are some of the benefits of semantic knowledge graphs? Well, primarily the ability to operate at this level, the semantic level, this thing-based level, where we're operating with meaning rather than just plain text strings. And that allows us to do some pretty cool stuff, like discovering insights in unstructured content. So this idea, if you don't know what you don't know, we can make connections across otherwise siloed content. So documents in one collection can be semantically related to documents in another collection, even if they don't use the same words. We can use these semantic connections to improve overall findability and relevancy by applying the technology to kind of standard search scenarios. And then other set pieces, we're all familiar with the idea of Amazon and Netflix saying, you know about this or you like this thing, here are other related things, a recommendation engine, and semantic knowledge graphs can do all of that kind of stuff as well. So again, a kind of ready-to-go data science toolkit. As part of my role at Kin + Carter Solstice, I lead our practice around decision intelligence. For us, this is about creating intelligent contextual digital products, if you like, which turn information into better actions and improve decision-making in our day-to-day world. But this manifests in many different ways, but it can simply be an employer or customer searching to find the most relevant information to make a business or purchase decision. A bit like how Google helps us find really high-quality content and apply that to our own decision-making. So if we're able to operate at this higher level of findability and leverage the semantic relationships, then we can connect users to more relevant information to make better decisions. Hence, semantic knowledge graphs are really a powerful tool to add more intelligence to search. Well, with that, I'd like to just hand over to Justin, who's going to tell us a little bit more about how we actually apply this in the product. Justin?
Thanks a lot, Carl. And I'll take a couple of slides to talk about LucidWorks Fusion. And you can see here, I'm saying a new type of knowledge management, and I'll talk about how that's new. And I've juxtaposed that with an old type of knowledge management with the encyclopedia. So just to kick this section off, LucidWorks offers an advanced AI-powered search platform, and our customers use Fusion primarily for digital commerce and digital workplace solutions. Digital commerce solutions, of course, help convert website product searching and browsing into higher click-throughs, better conversions, and more revenue. And some of our customers using us for digital commerce include Lenovo, REI, Home Depot, and others. And our digital workplace solution helps organizations provide their employees easy access to the information they need to do their jobs. Lots of government agencies as well as major corporations that have hundreds of thousands of employees using that to make that information more available and more personalized for their workers. So we know that this is a sophisticated system to build because we've been at it for about 13 years now. And many might consider building their own digital commerce or digital workplace systems that for AI-powered search and discovery, like what Fusion offers. But like I said, we know from more than a decade of hard work on this stuff that it's very complicated and requires a lot of deep domain expertise as well as technical expertise. LucidWorks, as a company, we began with a deep understanding of search and Apache Solr, which is the open source standard for big data search. And we wrote code to ingest data generated by systems, humans, and applications, so the data side on the left hand of this diagram. We've developed the advanced functionality for indexing, clustering, classifying, faceting, filtering, all that information, and use that for relevancy, ranking, analytics, visualization, NLP, the type of thing that Carl referred to, and ranking and boosting results. We've bundled it all into the platform solutions and user applications that are now available in LucidWorks Fusion. And because we've already done the work and become the experts at delivering the solution to some of the world's largest e-commerce and digital commerce operations, our customers, our new customers, can begin using our platform without diverting time, attention, and money away from their core business. And we say we want our customers to focus on their brand and their customers instead of developing another platform for search. So this is the complicated view of it. Our customers experience something more like this. LucidWorks Fusion incorporates AI and machine learning throughout the platform to intelligently ingest, explore, and curate the data. So when you ingest data into the Fusion platform, it uses ML at that moment to cluster, classify, and organize the content so that it will be available for user queries. Once the query comes in to Fusion Server, the reason that AI is mentioned again 2 clicks to the right is that AI is invoked again at that point to understand the query intent and personalize results. And I'll give a couple of examples in a minute. Fusion App Studio is the front end that allows teams to quickly create new personalized experiences for different types of users, customers versus employees, different workflows, et cetera, all accessing the same corpus or index of information that's in Fusion Server. All of this can either be deployed on-premise or as a multi-tenant cloud managed service that we would manage for you. So we designed this platform with personalization in mind, personalizing the experience for shoppers on the digital commerce side, personalize the experience for workers on the digital workplace side. And what we really do is we abstract all the complex technical detail that's listed here on this slide. So the NLP, the document classification, the anomaly detection on the far left when we're doing AI on the data when we're originally setting that up. On the Fusion Server side, we're handling ETL pipelines, search engine, data processing, a SQL engine, rules engine, et cetera. So I won't read through all this, but you see the end-to-end complexity that comes with the platform. And then we make all those operations scalable via extensible architectures that can scale either over time as demand grows or at peak periods of the day or of the month or of the year. All this is available in cloud. We do cross-data center replication and also advanced security to make sure that users without authorization to see certain information don't see that. In fact, they don't even know it exists, whereas more advanced users can see a broader breadth of information. So that's LucidWorks Fusion 101. Let's go back now to how this plays into knowledge graphs. So as I mentioned or alluded to, LucidWorks Fusion can predict the user's intent and match that intent with the best information available in the system. And Fusion understands content in context. So via keyword search, the system indexes all the information. It also understands the user based on signals sent by that user as she interacts with the system, and also all previous signals sent by all prior users. So the system is learning from the interaction, from the words that people are typing in a text box, how they're browsing the content, how they're clicking on facets. All of those signals are available to make the system more intelligent. And that stands in contrast to the example Carl was giving before of those kind of hand-coded rules-based systems that are going to be they're going to be pretty brittle, and as user behavior and user intent changes over time, they're going to have a really hard time keeping up with all of those inbound signals. So content understanding combined with user understanding allows for personalized search. And that means that Carl and I could type the exact same search query into Fusion, for example, and we would potentially see very different results based on our session behavior, what the system knows about us as users, etc. And of course, this webinar is about the knowledge graph, which uses machine learning to build an ever more precise understanding of the domain. While semantic search is a critical component for driving domain-specific relevance, there's much more to relevant search than just understanding the domain-specific semantics. And merging traditional search and feature boosting with user preferences for personalization discovery will help you deliver a much more relevant user experience. And that's done by really being able to bring all these things together and understand user intent, match that intent to the best available information. LucidWorks Fusion does that with machine learning. It's integrated throughout the platform, and it creates connections from our data, connecting our content via signals generated by the user interactions with that content, and provides that highly personalized experience to the end user. So you've joined to hear about knowledge graphs, and I'm talking about one specific variant that's big in Apache Solr and has been developed by some of our architects at LucidWorks. Let's look at one specific example of how the semantic knowledge graph can help with query expansion. Now, some of you probably know what query expansion means, but some of you might be scratching your head right now saying, what's query expansion? So let me throw out a few terms that we'll use to build on as we go further into the presentation. These are some pretty simplistic definitions, so if you're a search expert, bear with me, but they'll help all of us understand the two real-world examples that I'll go through. So alternative labels, for example, are substitute words with identical meanings, and that is the system knows that CTO is the same thing as a Chief Technology Officer. Synonym lists, which are also managed very powerfully in Fusion, provide substitute words that can be used to represent the same or very similar things. For example, Homo sapien is a synonym for human beings, and we use that in Fusion to do synonym detection. If you typed in the word Homo sapien, we don't expect the content to contain exactly Homo sapien. We can return results that are for as if you typed in human. We know that those two things are synonyms and treat them as such, and can provide more relevant results as a result. Moving down the list, a taxonomy classifies objects or concepts into categories. For example, Javier is a human, human is a mammal, mammal is an animal, and these ontologies are a key part of knowledge graphs represented by the nodes and edges that Carl introduced earlier. Speaking of ontologies, that defines the relationships between types of things between the Thames and London Bridge, for example, or back to our animals analogy, animals eat food and humans are animals. And then finally, the knowledge graph. The knowledge graph is an instantiation of an ontology, and it contains the things that are related and describes those relationships. For example, John is a human, and John eats food. Okay, with those definitions out of the way, let's go to an example query, and let's talk about how knowledge graphs can be used to expand this query. The LucidWorks annual conference is called Activate, and it will take place this year in Washington, D.C. from August 31st to September 3rd. I'll be there. We hope many of you will join us. We're already selling tickets to that and soliciting speakers. So let's suppose I'm being very proactive, and I want to start planning our team dinner for when we're there at Activate. So I would search for BBQ near Activate. And this is an example of what might be happening behind the scenes for the semantic knowledge graph to interpret what that means and provide the most relevant results. So near Activate, of course, human beings understand what that means pretty well. Machines might have a hard time with that because those are somewhat ambiguous terms. And here's how a knowledge graph might interpret that and make meaning out of it, make it useful. So first, and this is an example of a more hard-coded system that would list that near is something having to do with location. And then it can traverse from that near concept to understanding what Activate is. It's a conference, it's an event. So this is an example of traversing from one node to another, vis-a-vis the relationships that have been established. And now we need to find out what this event known as Activate is. And so we can traverse to the Search in AI conference, and we know that the venue is the Washington Hilton. And then I can traverse again from the Washington Hilton, and I could actually find the coordinates of the Washington Hilton. Now, of course, I won't go through all the other steps, but now that we know where the Washington Hilton is, from here, we can look for barbecue restaurants near that location and return the most relevant personalized results. Absent this intelligence, you might get results about Korean barbecue in Seoul or some other non-content specific example of barbecue. Now let's go to use case number 2, and this is an interesting extension of the example I've just given. Let's take a look at a second way that SKGs can be helpful, namely query disambiguation. How does the system know what I mean by BBQ? It had to guess that I meant a restaurant like this one, which happens to be the place where I used to get brisket when I lived in Houston, Texas years ago. So we start with the same query, and let's look at it in a different way. What barbecue? BBQ. The system could take that in a lot of different directions. Maybe I wanted to know where I could buy a barbecue grill so I could take it home with me after the conference was over. Now, as a human being, you know that that's not the likely intent of me using BBQ. I'm most likely to look for a restaurant. But unfortunately, AI, machine learning, needs to learn that. It needs to be smart enough to understand context, which is a pretty human concept when you think about it. So here's an example of disambiguation and how a knowledge graph can help with that. So apologize for the small text here, but on the left-hand side, you see a series of information about restaurants, and BBQ is listed as one type of restaurant. Also in that highly biased definition of terms related to restaurants are brisket and ribs. To the right is the other category, which is outdoor equipment, and BBQ is listed there as well as grill, charcoal, etc. And so what you see here is the system can distinguish between two potential meanings of that string BBQ. There's a restaurant, BBQ, brisket, ribs, pork, and there's outdoor equipment, BBQ, grill, charcoal, propane, etc. Looking at it another way, I apologize for the word wrap on restaurant. All of these words can fit into the category of restaurant, and all of the second set of words can fit into the category of cooking device. But the system needs to find the best relationships and the best words, and it does that by traversing the knowledge graph, looking at the weights of those words in the context of the search I've just provided. And the ones that I just highlighted in red, of course, are the ones that are relevant. So for our example query, each of the words then there in red will be the most important in the ontology for this particular search, and they would each have weights that would help determine the most relevant results. And here's the most important part, and the reason why Fusion is going to be so much more powerful than a hand-coded, hard-coded rules engine. Fusion will make an educated guess based on the nodes, graph, ontologies, etc. If the user does not find the results effective, so for example, if I click on the outdoor equipment rather than the restaurant, if I click on the fifth search term rather than the first, the system uses those signals to adjust the graph and become more relevant, adding new nodes, changing the weights of those existing nodes, etc. Let me keep the questions coming in. I see some questions coming in. Thank you for those. Keep those coming in. We're almost at Q&A time, but I did want to give one example of a LucidWorks customer. And this is not so much to focus on whether or how they've used SKGs, but to talk about one example of a customer that's really using Fusion to straddle the digital commerce, digital workplace world. So they're using Fusion for support, and that means that their Red Hat customers, customer-facing, are able to query this information and serve themselves, answer their own questions. And their support team is also using back office to better answer the questions that don't get deflected on self-serve. You can see here this slide is a little bit old, but we're very proud of it. It's about 5 years old now. When they implemented Fusion, the customer portal daily click-through rates improved because the results there were more relevant, more useful to folks. And because that click-through rate improved, they deflected thousands of tickets that would have gotten through to a pretty sophisticated support agent to solve. And if those questions are more like, what's my login, things like that, that's time wasted for the organization that they can't use to solve their customers. So what did that mean? Like I mentioned, a 200% increase in click-through rates, a 91% reduction in total cost of ownership versus the platform that they're using before. In a very short period of time, 50,000 fewer support tickets. Now, like I said, this data and this graph is old, so draw that forward 4 years, they're doing much more sophisticated things than when they originally launched beginning. So I'm going to assume that those ticket deflections are far larger by now, and they've grown over the last 4 or 5 years. And it also improved customer satisfaction. So one more slide just to wrap that up, and then we can get into starting to take questions. How did they do it? Now, I've mentioned signals. Signals are very important in LucidWorks Fusion, also related to the knowledge graph that I mentioned. Signals are the lifeblood of making something relevant and keeping it relevant on an ongoing basis. So in the Red Hat example, they're able to measure impressions when content appears in search results and how it's interacted with. Those real-time signals about how people are actually using content are going to let the system handle that at much larger scale. Even if you had hundreds of folks curating that data by hand, they're never going to be able to keep up with the volume that Red Hat's seeing. And so they're always going to be a little bit out of sync with what people are asking for and what results are most important to them. They're able to boost documents with higher than average read speeds. A lot of that comes from the core of Apache Solr, which can operate at very high speeds, and use that as an indicator of relevance. So one thing I want to point out is this is great for the actual support function, but the other benefit that Red Hat as the organization writ large is getting is they're getting a steady stream of information about what their customers care about. That can be used in product development, that can be used in broader marketing activities, that can be used for all sorts of things outside of and beyond just the support function. And then the last way that is that not every click is a good click, so they can build a model in Fusion that identifies docs that people don't read and degrade those to improve content quality, boosting up the documents that are in fact more relevant. And that, of course, has a very virtuous cycle. So as they're doing that, they're getting better engagement with self-service and making that more powerful and preserving more time to answer the really difficult, newer questions that maybe the system hasn't been trained to answer yet, and it still need a human being to answer those more difficult questions. All that knowledge flows back into the organization. All right. Well, that concludes our prepared remarks. Let's open it to the questions. We have hundreds of participants, so we won't open the lineup. That's why we have a Q&A portal open. So please ask questions. Mary Dee, I'll turn it back to you. Can you field the questions and tell us which ones we should answer?
Absolutely. And just as a reminder to the people who might have a question, type it into the question box provided, click on that submit button. So here's a question for Carl. This person wants to know, can I generate a semantic knowledge graph using one collection of content and then apply it to another one?
Oh, great question. Yeah, so the way that knowledge graphs actually manifest out there in the real world is as a separate, think of it almost as this kind of conceptually separate structure to navigate your content. So in effect, you could derive an SKG, a semantic knowledge graph from one collection, and then use that information as part of the, if you like, the query cooking process that Justin went through and apply that to an entirely separate collection. So yeah, lots of opportunity to get really creative with that. But the key to it is to think of it as a separate structure that's derived from one collection and can then be applied to anything else.
Okay. Justin, what are some of the ways that geospatial or location information can be used in a semantic knowledge graph?
That's a great question. Thank you. This one is near and dear to my heart because I came from a geospatial analytics company before coming to LucidWorks, so I was bathed in this for a year and a half. Think of location as just another edge or another type of node that you can have in establishing the relationships between things, people, products, etc. And location is, pardon the pun, but it's the last mile. A lot of relevance has to do with where people have to be, where people are at a particular point in time. So, for example, I was giving the example of the barbecue in DC. If the system knows where I am, it can effectively personalize the results and add context that other systems can't add. And so that is another way, because it's a category or it's a concept that's relevant. Our customers, especially on the digital commerce side, are finding really exciting ways to provide more relevant content. They can, for example, if they understand the location of a digital user searching for products, they can match that with in-store availability of those products or in-store promotions. And so it really goes a long way towards tying brick and mortar to a digital always-on type of channel. Other examples might be if you're looking at managing a big fleet of vehicles that need to be repaired or maintained. This might be a major automaker. A top 5 automaker is a customer of ours, and they're looking at warranty claims and defects in their vehicles, understanding where those defects happen or where those vehicles were manufactured, bringing that geospatial knowledge into it can provide a lot more insight for them in serving customers or making improvements to their vehicles.
Mm-hmm. Yeah, I can see where that would be really helpful, yes. Here's an interesting question. It starts out with a compliment. Knowledge graphs are great and really tell a story, but some come off as very technical. So the question is how to translate those to non-technical executives. Carl, I think that's up your alley.
Yeah, sure, I'll take that one. So this is a great question, and I mean, arguably the space that I spend a lot of my time in, operating at that strategic level, trying to map and unpack, if you like, complex technologies to solve business problems. So trying to get the language right for this sort of stuff is definitely tricky. But when it comes to search, I usually go and hang my hat on Google. So everybody understands Google. We use it every day. It's kind of that implicit way that we expect search to work. So when it comes to knowledge graphs, there's two things that you can do. The first is to introduce the idea that, you know, when you type something into Google today, it has the concept of things, places, people, movies, companies, all those sorts of things. So it's a concept we're familiar with. So the idea that you're working at that semantic level, and search is not just about a list of results. Sometimes we want to know about something very specific. So I think seeing how Google does that is great. But I think then just more generally, the idea of lifting the conversation to, you know, the concept of meaning. So search up until, you know, from the year dot until recently has been about you type in a word and you get stuff back that matches that word, 10 blue links. And yet as humans, we have a very rich language, very semantic language. We use lots of different words for the same thing. Justin had a great slide for that. So I think the idea that you can say to an executive, you know, you can find stuff without having to actually use the words that are in the document or web page or whatever it is. Just use the words that, you know, that you think are in the right kind of space. And you're breaking that link then between just string matching in search technology. But it really all does come down to the fact that as consumers, when we engage with search today, Google kind of does a lot of that sort of stuff for us. So, you know, that's really the benchmark.
Mm-hmm, mm-hmm. Justin, did you want to add anything to that?
Yeah, you read my mind, Carl. That was an excellent answer. And I come from more less of a technical background and more of a business background. And the way I would answer that for maybe a different audience is that, just like my barbecue example, have a couple of those real world examples where you're showing the effects of a knowledge graph without necessarily having to show a complex architectural diagram of how it actually works. Now, there are, of course, some audiences want to see that diagram, others really don't, and they want to know how's this going to change my business. So I gave a sort of a funny example of finding a barbecue in DC, but you can tell those stories with your own domain examples pretty easily, and it's very powerful in my experience.
Yeah, and I think, you know, since the question was about non-technical executives, I think the premise would be that it would be a story that would appeal to whatever area that non-technical executive was in.
Exactly.
So I think this
and
is
because
sort of
we're talking about building a graph of language, everybody knows how they speak and the terms they use, and so you can make that personal to even down to the individual executive. You probably know the things that individual cares about, and you can give an example of a knowledge graph that would make that concept easier for others to understand.
Yeah. Good point. Okay, this is sort of a follow-on question, I think, and I'll address this one to Carl. Given that knowledge graphs are such a powerful tool, and some of the benefits may not have been obvious at the beginning of this webinar to everybody, the knowledge graphs, is this an area of technology that you expect to become increasingly popular in search? Is this the future of search?
Yeah, again, another great question. So it's like the yardstick I have for this is really maturity, and kind of following on from my last answer, really. We've moved on from a world of typing in keywords to just typing in something into the search box, and we expect the technology to do clever stuff for us, be it give us an answer to a question, tell us about a thing, show us the most relevant list of results. The reality of search platforms today is that you need more tools such as semantic knowledge graphs to provide that kind of functionality. So, again, the likes of a Google makes it all look nice and simple behind that, white page in the search box. But when you're trying to build that kind of stuff yourself, you do need to bring in other technologies now to get anywhere close to the expectation we have for search results and answers. So yes, 100%. This is. Knowledge graphs have been around for quite some time. Google introduced theirs in 2012. Very much starting to see this now filter through as part of what customers expect to see in search solutions. And if they don't fully understand the idea of graphs, they certainly understand the idea of the problems that graphs solve. So yes, going to see a lot more of this stuff as we go forward. Okay.
All right. Very good. Yeah, I look forward to that. Well, here's a question that's definitely for you, Justin. This person says that he may have missed this because of his login, but can you show the front end of your system? What was the interface that Red Hat was looking at? So could you help him out here?
Yeah. Unfortunately, well, the good and the bad is that Red Hat, as a customer of ours, they own their experience and they own their data that's generated by Fusion. So that's good for them. It means that, particularly on the digital workplace side, we don't have as much eye candy as we would like because that belongs to them, and we don't go and take screenshots of what they're using behind the scenes. And I could probably find some front end Red Hat customer portal images. I didn't include those in the slides. But let me answer that in a more general sense. You can certainly find the experience on our consumer side, because that, by definition, is public facing. So companies like Bed Bath & Beyond uses us. You can search there. I mentioned the Home Depot. So those public sites will give you an example of, and REI, the outdoor equipment company. Those are really good ones just to see the difference. And what I encourage folks to do is compare that with other sites that they've tried to shop on that don't give them very good experience, and just see what the difference is. Now, of course, that's in a commerce context, but you can abstract it to the digital workplace side. Now, two other things I'll say in answer to that question is we are working to provide a lot more eye candy, case studies, public testimonials. That's something that my team is going to be working on a lot this year. So there'll be more of that those types of visual examples on our website. Also, the Activate conference in September is a great example because we had about a fifth of the attendees at this year's conference were LucidWorks customers, and a lot of those speakers were showing the results that they got and giving lots of screenshots and examples from their own personal experience. Now, the one last thing I'll say is this might have been when you were having trouble logging in or you dropped off for whoever submitted this question, but our App Studio is a UI builder. So it's UI builder. It's also a UI platform to manage relevancy, to boost and block keyword terms. So it is very much a user interface that can create different versions and different ways to interact with the data that's in Fusion. And we see customers use that, differentiating that experience for different user groups within their company, or creating different entry points to the customers they serve externally, differentiating that experience. So certain customers that are in different parts of the business get different results than than other customers. So it's really a very flexible tool to provide different types of access to the information to different audiences.
So highly customizable, is that what I'm drawing from this?
Very highly, highly customizable, easy to use, and it comes. Fusion comes with pre-built templates, so you don't have to build it from scratch. We've solved a variant of this problem for dozens of digital commerce organizations and hundreds of digital workplace organizations. And so we provide that knowledge to our new customers via templates that are getting them most of the way there for kind of repeatable use cases, and then they can extend with their existing visual design team or their existing data scientists. They can extend by creating new applications, new interfaces very easily based on their domain expertise, which we're never going to have that level of domain expertise in-house.
Yeah, sure. They would know their own business, I would hope. Yeah.
Exactly, yeah.
Okay, well, if we've got another question here. This is, what is the difference between a semantic knowledge graph and an enterprise knowledge graph, a SKG versus an EKG? I'm not sure which one of you wants to take that one.
We probably
Carl, I'll let you take that one.
Go, Carl.
Yeah, Carl, you start, and I'll pile on. Yeah.
Okay, fair comment. So, yeah, I mean, again, great question. This is something which I touched on, but the reality here is that, I mean, knowledge graphs, enterprise knowledge graphs, if you like, you'd require another data store typically to build a knowledge graph. There's lots and lots of those out there. And it's a somewhat arduous process to populate it. As I was kind of intimating, you can use NLP to process piles of documents and extract facts and relationships in RDF triples, if you're familiar with all of that kind of stuff. So simple answer is you can create another data store to do this, and you can get quite cute over the sorts of things you can do, adding metadata and such like. But that's a heap of work. The great thing about a semantic knowledge graph is it's kind of there already in your index. It's just not in plain sight. And what LucidWorks does is effectively lift that out for you automatically, give you a toolkit, an API you can go and engage with straight away, and you can deliver, some of those use cases that Justin's talked about straight away. So it's kind of, I would say, time to value, and also the fact that it's already there. You don't have to do a ton of work. There are always going to be specific use cases that sit well with one approach or the other. But really what we try to focus on today is how you can get maximum benefit out of the platform, and let the technology do the heavy lifting in creating those relationships and finding those concepts and things in your data. That was my answer, Justin.
Brilliant answer. Let me add one. Let me take it in a slightly different direction and just expand it a little bit. A lot of organizations, large, sophisticated organizations, still struggle with adopting machine learning and making machine learning ubiquitous within their organization. Now, we mentioned Google several times. That's not one of those companies that's having that challenge. They've been doing this for a while. What we work with our customers on, we really advocate more of a product-based approach to developing machine learning versus the more traditional project-based approach to bringing machine learning into the organization. Now, what is the difference between those two things? The project-based approach was, let's figure out a problem that we want to solve with machine learning. Let's hire some data scientists that'll try and build models to solve that problem. But you have a kind of a cross-functional interpersonal risk here, because the business sometimes sets out the business problems. The data scientists might not fully understand that. They build models that solve a slightly different problem or don't solve the business problem in the right way. And then you have to go to the IT or the DevOps team, and even if the business and the data scientists become aligned, they might develop models that are very consumptive from resources and are never going to work in production. And they come over to the DevOps team and they say, you got to be crazy. There's no way that we can ever make this work at scale. And so that is a project-based approach, and some of the risks of adopting through that. We say, if you adopt Fusion, you get a product that already has dozens of Spark jobs integrated into the platform, and they've already been trained and perfected on some of the largest organizations in the world. So you get out of the box that capability. And by the way, and this, Carl, you alluded to this, the search and browse activity of the users is a constant, steady stream of training data. So you don't have to go out and find a data set in the wild and curate it and make sure it works and do all the cleaning that is involved in preparing data to train models. You get the data flow along with the models, and then those three teams I mentioned, the business, the data scientists, and the DevOps or the ops teams, they can collaborate around something that's already working and extend it out from there. So what we find is that dramatically accelerates the adoption of a more general machine learning approach within large organizations that tried to do this several ways before and have been stymied.
Well, I would think Google would have a little bit of an edge there because it probably gets more queries than anybody else.
Well, and that's a great point. And you know, Google and Amazon will come up in this conversation. Here's the difference. Both Google and Amazon are serving a very general audience. And so their opportunities to personalize that experience are far lower than, say, a Lululemon that has been building its brand, that understands its customers very well. They can offer that same type of personalization experience as what Google has built or Amazon has built, in the context of knowing their customers, and that all goes back to the brand and the experience. And so that is a way for organizations to counter whatever fear they might have of those larger organizations with hundreds, if not thousands, of data scientists. The thing that they own is their brand and their experience, and we can help them make that brand and experience. And by the way, sometimes I'm referring to the e-commerce side, but there is an experience of working, and we've all been in organizations where finding information is really hard and painful, and that affects our morale at work. And if it's bad enough, we might start looking for another place to work. We believe, and our customers have told us this, that with the digital workplace solution and knowledge management, it makes people more productive and more satisfied at work, and that benefit is a little bit harder to quantify than items added to cart. But it's very real.
Yeah, I could see that for sure. I've got another one here, Justin. Other ways that an SKG can help users besides the standard text search box?
Oh yeah,
that's
a great question, and that's something that we have talked about LucidWorks ourselves as a search company, but that's a double-edged sword because people think of the box, right? And they think of Google immediately. A semantic knowledge graph is just a way of relating information, and we can push that information out in lots of different ways other than a list of search results from a text box. So browsing is a great example. If you're interacting with a site and there's facets that help you browse through the content that's provided, that is something that people think of as static, but we make that dynamic. So similar to how I said Carl and I could type in the exact same text in a search box and get different results, we might get different facets for browsing based on who we are. And so it allows us to navigate in a much more personalized way. And then I haven't even mentioned proactive recommendations, but we can power that as well. We can do the others like you have also appreciated this type of content. We're used to that in a commerce setting, but we can do that in a workplace setting too and help employees find people that might know about the stuff they're looking for. In a very large distributed organization, it's impossible to do that with a stack of notepad or sticky notes on your desk. You need a digital way to do that.
Definitely. So true. Okay, well, that is all the time we do have for questions today, and we apologize that we were unable to get to all of your questions. But as I stated earlier, all those questions will be answered via email. So I would like to thank our speakers today, Justin Sears, VP Product Marketing of LucidWorks, and Carl Hampson, Director of AI, CTO, Solstice. If you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. Plus, you will receive an email tomorrow with the URL to view the archive within approximately 24 hours. And just for participating in today's event, you could win this $100 American Express card. The winner will be announced on January the 31st, and we will reach out via email if you are selected as this month's winner. And thank you again for joining us.
Thank you, ladies and gentlemen. This concludes today's webcast. We appreciate your participation. You may now disconnect. Presenters, please stand by.